Um, all right. Well, yeah, you two have my undivided attention for an hour, I guess. So ask away. Anything, any particular problem you want me to go over? Yeah, and if you see my arm outstretched or me like turning to my side, I'm petting this little thing here. She's just sitting here doing nothing. But anyways. Uh Yeah, any particular questions you want me to go over, types of questions?
It's like August 2023, 6B.
Okay, 2023, which one?
August
August, all right, and which problem?
6B. It's just that the
Oh,
product
6B, okay, 6B. Sure, what is 6? Okay, yeah, that's definitely one of the harder ones, but um it's still good to go over. Okay. Yeah, okay. So the trick, let's see. Yeah, okay. Do this. Um, yeah, so definitely the trick is to use A. Um, I forget if you have to use it for both F and G. Um, but I guess there's no reason not to. So yeah, we'll do that. Kind of thinking kind of like the way you guys would be thinking, if this was asked on prelim. Um, but okay, so yeah, let me do this. So yeah, 6A was homework, so I won't go over that. Um, okay, I'll just go back and forth. This okay. So the goal is to prove the following. Yeah, I do want to emphasize this is definitely, I would say, for one of the harder ones. I mean, there's no super easy like shortcuts. It's just I just got to plow through it. So for any eta, I think bigger than 0. Um, just the usual definition. Uh, yeah, it's on 0 to 1. So this measure here. Right. So we need to show that this is equal to 0. All right. So let's say epsilon is bigger than 0. So yeah, let's go to 6A. So, yeah, let's do this for F and G. So I might not, it might add up to like 4 epsilon or something. On a prelim, I wouldn't worry about it. And especially, yeah, that's not a big deal. Obviously. So yeah, we'll do yeah, so we'll use 6A. And the key point of 6A is that basically you're allowed to assume that or it allows you to assume F and G are bounded. That's really, really, really important. Otherwise, I mean, you really just need that. Right. So pick these two. Um, right, where this here this is less than epsilon. And same thing for G. Yeah. All right, so yeah, so to maintain sanity, let's call these something. So let's say this whole set here, let's call it A. So let's call this A1, A2. Um, yeah, okay, so sorry, let's see. Yeah, it depends on n, so let's call it AN. Okay, so let's see. Maybe not the best thing to call this. Call it A. Sure. Okay, so the measure of AN, let's say it's the measure of AN. So it's either intersect or intersect and then take away. Um, okay, so that's less than right. So the measure of the first one is at most 2 epsilon. Right. So we're away from this union, so is everyone okay so far? just using 6a twice. And then you can write an as an intersect the union of these two, and disjoint union an take away the union. These are both, of course, measurable. Everything's measurable here. Yeah, everything's measurable. So yeah, intersect the union and then take away the union. So no problem. I mean, even if things weren't measurable, you could actually just use subadditivity, but okay. Yeah, so what do we know? What do we know is true on this set here? Kind of trivial from what I have above. But if I take away the union, then what do I know is true? So yeah, if I take away the union here of these two sets, what do I know is true? Well, we're away from both of it, so X is not an A1 prime. So this is true. And we're not in A prime prime. So this is, we're not in this set. So this is less than or equal to M2. Right. Okay, now we can start. So is everything okay so far? This is kind of the key to making this problem work. So all we need to do is basically show that this limit is 0. And then we'll have, if you really want to be precise, the lim sup is less than 2 epsilon for any epsilon, and hence the limit has to be 0. You don't really have to use lim sups, but that's the kind of the point. I want this now to converge to 0. And because we can assume, well, not we can assume, because F and G are both bounded on this purple circled set, bounded by M1 and M2, that's going to make it possible. So is it okay what I'm doing so far? Kind of making sense, just using using 6a twice.
Yes, that makes sense. Thank you.
Yeah, okay. Okay, so yeah, so let's start yeah, as I said, we might not even need both of these, but I don't have the solution written down, so this is the way I would think. You know what? The hell with it. Is this even we might not need it, but I have a feeling we do. Why not? Just having bounded functions here definitely for these kinds of add and subtract arguments typically makes life easier. For example, showing like the product of uniformly convergent sequences of functions is uniformly convergent. You need to assume one of them is bounded, uniformly bounded, then the product of uniformly convergent sequence of functions is uniformly convergent. There's basically the same kind of thing going on here. So typically you add and subtract Fn g of x or f of x gn of x, doesn't matter. So add and subtract this. So we're gonna run into what would look like a problem. It's really not. A little tricky. Let me kind of review here. So yeah, for these whoops. Sorry, that does not make sense. Subtract and add it. That makes a lot more sense. So here I factor out an Fn. And that might be a little worrisome because we don't know that Fn it's actually bounded. That's okay. Less than or equal to this. Now I'm going to factor out a let me get rid of this. Factor out a let me see, what am I factoring out? Yeah, factor out a g of x. It's, okay, but yeah, what we could do is just do add subtracting one more time. Because there's no control over the absolute value of Fn of x. Unfortunately, there just isn't. All we really have is this. So I'm just erasing that. Yeah, this is all we have. So we really have to get we do have to get F into the game here. So yeah, what we do is Fn of x minus f of x plus f of x. And I use a triangle inequality here one more time. I'm not going to touch this. This just gets, what I'm circling here gets left alone. Because this is really as good as we could want. Fn goes to f in measure. So that's good. G of x, it's bounded by M2, so we'll take care of that in a minute. So yeah, we're just gonna do that here, the triangle inequality. Yeah, Fn minus f. Gn minus G. That. And I'll throw the f of x, sorry, g of x. Throw that away in place of m2 in a minute. Fn minus f. Yeah, so less than or equal to m2. This is less than or equal to m1. So this is less than or equal to Fn of x minus f of x times Gn of x minus g of x. M1 and then M2 right. Um, all right, so on this purple circled set here, this is going to be less than or equal to all this here. M1 plus M2 let's see. Yeah, let's give this a name too, I guess. AN tilde, I guess. Okay, right. So, okay. Right, so let's use that, that we have convergence in measure of Fn to F and Gn to G. We have not used that yet. Yeah, okay. So, let me see. Yeah, so let's so if this is less than let's see, easiest way to do this. Seconds. Yeah, okay. So we need to do some manipulations with set inclusions, nothing too bad. So in particular, um, right. So the claim is then, yeah, so remember, in particular, we're here, so we are assuming this is going to be bigger than eta, but still F and G are bounded by M1, M2. Because we're here, but we're taking away those two sets where it's not true. So the claim is that A and tilde has to be a subset of well, really the set where this is bigger than eta over 3M1. I'll call that B N. I'll explain what that is in a second. Same thing for Fn. And well, we want this, so yeah, we want the product of these two. So let me explain what I'm doing here. Let's say X in 0 to 1, where Fn is bigger than, let's say, the maximum of yeah, so I want this to be smaller than eta, so let's say square root. And I want this less than, well, I want, I want to add up to less than eta. So this is so same thing, but for that doesn't make sense. Sorry, that should be F. Yeah, I'll explain what's going on in a second. It's not clear. So it's like a 3, that's eta. And the whole thing is square rooted. Um, Yeah, because okay, so let's uh yeah, so let's say X is an AN tilde. But X is not in the union. Well, I claim that's a contradiction. Because we have this is less than or equal to all this. Okay, so yeah, so yeah, so trivial here what I'm doing, but the point it's not in Bn and X is not in Cn. All right, so X is not in Bn and it's not in Cn, so both of the so both of these here are less than or equal to the maximum. So they're less than or equal to the both of them. That's, I think you want the minimum, sorry. Yeah, you want to be less than or equal to the smaller one. Uh, yeah, sorry. Okay, so yeah, if we're away from this, then this is less than or equal to the minimum of these two, so it's less than or equal to both of them. So in particular, this and this is less than or equal to eta square root eta over 3. So let's see what happens. This is less than or equal to eta over 3. This is less than or equal to eta over 3 square root. Okay. But this is less than eta over 3 m2. Or uh, yeah, sorry. Yeah, this is less than or equal to eta over 3 m2. So this is less than or equal to eta. But this is also less than or equal to eta over 3 m2. So the point here is that, well, this is just 8 over 3. I'll even do it here. This is 8 over 3 and 8 over 3. Okay, so that means that X is not in AN tilde. If we're in AN tilde, we have to be in AN. And if we're in AN, this is bigger than eta. Okay, so that's really the whole kind of, I guess it's like two major steps. One is I guess three major steps. One is to kind of define these sets here so that essentially we're allowed to assume F and G are bounded. Then we properly multiply, add and subtract stuff to get to here. And then we kind of cleverly pick these sets here to get the set inclusion. Because if X was not in either of these, one or the other, could be both, but if X is not in union, it's not in either of them. And that means, you know, that means basically Fn and Gn are kind of small or not too big. That kind of forces X to not be an AN tilde because, well, all these combined together give you it's less than or equal to eta. Great, so we have proved this here, and that's really the key. Sorry, Bn and Cn. All right, so let's put everything together. I guess I really should do lim sups, but whatever. So this is less than or equal to, go back, 2 epsilon, whatever. Yeah, or what you could do also, so maybe this is a little clearer to do. Don't really need to take limits necessarily. Pick n. Well, let's just do epsilon. We'll add up to 4 epsilon. I don't care. That's fine. So we can make these as small as we want. Because, well, we're assuming Fn goes to F in measure, so the limit of the measure of Bn is 0, no matter how small this is, and the measure of Cn as n goes to infinity is 0, no matter how small this is. That's the definition of convergence in measure. So we're taking full advantage of that. So that means the measure of An less than or equal to 2 epsilon plus the measure. Sorry, give me a second. I gotta plug my laptop in. Die. Yeah, and we said An well, it was An tilde. And we cleverly got that. This is less than or equal to 2 epsilon plus these two. And that's less than epsilon. Sorry. 2, 2, 1, 1. Yeah, so you probably could maybe define these sets in a more efficient way. Or label them, not define them, label them. But yeah, I mean, I don't think there's really any shortcuts or any more efficient way to do this. Because I would, the way I would think is like each step that I've done was just born out of necessity. I need F and G to be bounded, particularly because when I add and subtract stuff, even if I do this little trick here of adding and subtracting f of x here, so I do like the usual 511 add and subtract, but then I do a further add and subtract here. No matter what, I'm stuck with an f of x and a g of x absolute value, and I just need that to be bounded. Okay. And if this is bounded, then yeah, I'm basically good to go using the definition of convergence in measure for Fn to F and Gn to G. Because then I can do this kind of thing here. And I picked these precisely so that if we're not in the union, then everything adds up to less than or equal to eta. And hence we're not an AN. Contradiction, because we assumed we're starting off in AN. Right. And then, now we're basically, after that, we're done, basically, because, well, by convergence in measure Cn, the measure of that goes to 0. Measure of Bn goes to 0. Not that it matters, but I guess Bn and Cn, not Cn and Bn. Yeah. So any questions? I mean, yeah, like I said, unfortunately it's long. I don't think there's a shortcut to doing this. You fill in all the details. Any questions on this? Does this make sense?
But yeah, makes sense. Thank you.
Yeah. I mean, I'll throw this up on YouTube. Could even make it its own, just like properly named video. It's a nice little result. Product of convergence in measure implies convergence in measure. Yeah. Forget if you absolutely need finite measure. I think you do. Yeah, you definitely do. You do need a finite measure. But anyway. Yeah, I guess I can answer a quick, like maybe a quicker question. I think if anyone has one. Maybe just like outline it or no. All right, well, what's it? So Thursday. Yeah, I'll definitely yeah, so definitely I'll have another one Thursday, last minute questions. But if you have any questions, just email me or I get emailed when someone puts something up on campus campus wire. So, but yeah, the only thing with campus wire, I don't think I mentioned this, for some very strange reason, you can't use less than, or it gives you an error. So I actually spent like a few hours trying to figure out why the hell I was getting errors. Really pissed me off, but anyway, so you can just, yeah, email me questions if you have it, or up to you. All right, yeah, no questions. Then maybe I'll see you guys Thursday. Yeah, and I'll update the YouTube playlist right after this. I'll put this one up too. Yeah, take care. See you guys later.